Welcome to all. The previous class we were discussed about the basic concepts of nuclear power plant and what are the merits and demerits of nuclear power plant, and also we discussed the nuclear fission and fusion process, and also we discussed the how the nuclear power plant will work, and also we discussed the what are the different types of fuels used in a nuclear power plant. Now let us move to the next concept, that is the nuclear reactor and its control. Okay, it is very important question. This is very important. In examination, they may ask the question, explain the nuclear reactor and its control operation with the block diagram. So it is an nuclear reactor. The basic block, the schematic diagram of the nuclear reactor. I think it is visible to you people. Okay, this nuclear reactor will contain the different components. So let us discuss one by one. The mainly fuel, it is here we are going to observe this is a nuclear reactor. The nuclear fuel we discussed already, the uranium is a major fuel we can use in nuclear reactor, and it's an uranium is a basic fuel. They usually uh, pellets of uranium oxide UO2 are arranged in tubes to form a fuel rods. Here we are going to observe the fuel elements. These are the fuel elements we are going to observe here, and here we are going to observe the moderator, and here we are going to observe the coolant. This coolant will work as an heat exchanger. What are the heat generated in the reactor that will transmit it to the coolant to the heat exchanging chamber. Here we can generate the steam. That coolant may be different thing, that may be gaseous, that may be some liquid, some that may be any hot water or heavy water, we can say heavy water, or that may be any types of coolant element. Okay, these are the different components we are going to observe in nuclear reactor. This one is an core, and these are the rods, control rods we are going to observe. It's a fuel element, the fuel tubes. So here the fuel will be installed in a tubes, so that the tubes will be installed in the core of the nuclear reactor. This one is an core. We can call this one as an shielding. The shielding is very important in order to avoid the leakage of radioactivity. So we are going to use the shielding in the nuclear power plant. Okay, it's a concrete wall. The shielding will be done by the concrete wall. And here we are going to observe the moderator. I will discuss the function of those different components one by one. And here it's a coolant circulating here. The coolant circulating to the heat exchanging chamber. In heat exchanging chamber, here we are going to observe, here we are going to fill the water. The heat generated in the nuclear reactor, that will be transmitted to the that will be transmitted to the coolant. Then heat will be exchanged here. Then water will be converted into steam. That steam is used to run the steam turbine. That is the working principle of the nuclear power plant. And the major components in the nuclear reactors are fuel, moderator, coolant rods, control rods, coolant, the pressure vessel or pressure tubes, and the steam generator and contaminant containment. Let us discuss one by one. The first one is the fuel. It's an basic uranium we are going to use. The rods are arranged into a fuel assemble in the reactor core. In a 1000 megawatt class PWR, there might be a 51,000 fuel tubes with over 18 millions pellets. If you come to the moderator, here we are going to observe. So we know the fusion operation, when the nucleus hit the atom, that atom will be split into two. At the time of splitting, it will generate the heat. So the chain process of this the chain process of the splitting of the atoms due to the heating of the neutron, it's a nuclear chain reaction. That chain reaction will generate the huge heat. We are extracting that heat to generate the steam in the nuclear power plant. So it's a chain process. Anyhow, in the nuclear power plant, we need to control that splitting of the atom. So we need an moderator. So it is a material in the core which slows down the neutrons, which slows down the which slows down the neutrons releasing from fusion, so that they cause more fusion. It is usually water, but maybe an heavy water or graphite. So that is the working of the moderator. It will slow down the neutrons in the core of the nuclear reactor. Thereby, it is going to control over the fission operation. Thereby, the heat generated in the core will be controlled. This is the working of the moderator. This moderator may be usually an water, but heavy water will be used. Heavy water or graphite may be used as an moderator. So here we are going to observe this is an moderator that is filled in the core. And then the control rods. I already told that the control rods will absorb the neutrons. The control rods here we are going to observe, we can vary the position of these control rods by varying these control rods, just like a piston operation. By varying this control rods operation, so it is going to absorb the neutrons. By absorbing the neutrons, it will avoid, it will reduces the number of neutrons in the core, thereby the heating of the neutrons to the atoms will be reduces, thereby we can easily control that heat production in the nuclear reactor. Okay, nuclear reactor. Okay, there's some definition be given here, I will read. These are made up of neutron absorption materials such as cadmium will be used as an coolant rod, hafnium or boron, and are inserted or withdrawn from the core to control the rate of reaction or to halt it. In some PWR reactor, pressurized water reactor, PWR is nothing but pressurized water reactor. I will discuss that concept later. The special control rods used to enable the core to sustain a low level of power efficiency. You should remember the major working of this coolant rod is absorption of the neutrons. By observing the neutrons in the nuclear core, it will reduces the chain reaction, thereby um, we can easily control the chain reaction, thereby we can easily control the heat production in the core of the nuclear reactor. And next, the coolant. I already told that this coolant here we are going to observe, this coolant will working as a heat exchanger. It will transfer the heat generated in the core to the heat exchanging chamber. What the heat generated due to the nuclear fission operation, that will be extracted from this coolant will be circulated through this pipe uh, to the heat exchanger. In the heat exchanger chamber, what the heat generated in the nuclear reactor, that will be absorbed by the coolants, that will be transferred here, and then once again the heat in the coolant will be exchanged to the uh, other thing, that maybe we may use a water to generate the steam. Sometimes we can use some gases to generate the some pressurized gas. Normally we are going to use an water here, so the water will be converted, the heat present in the coolant will be transferred to the water, and then water will be heated and it will generate the steam. That steam will be used to rotate the turbines, thereby we are going to generate the power in the nuclear power plant. These coolants may be an what's these coolant may be an heavy water, otherwise some liquid metal. We can use the liquid, we can also use a liquid metal as an coolant, because the heat absorption in the liquid metal is huge, and it will uh, mm, the huge amount of heat will be absorbed by that liquid metal. We can use that liquid metal as an coolant, and the different coolant may be used here. Let us see one by one. The fluid circulating through the core that transfer the heat from it in a light water reactor. The water moderator function also a primary coolant, exact of BW, or it's a boiling water reactor. Normally, uh, the different types of coolants will be used in the different types of reactor. We will discuss later. That is the major working of the coolant. It will transfer the heat generated in the core to the heat exchanging chamber. Then we are going to observe the pressure vessel or pressure tube. Here in the diagram, we are not going to observe that one, the pressure vessel. That is usually robust steel vessel containing a reactor core. It's a vessel, the pressurized vessel we can call this as an vessel. Okay, that has to withstand the huge pressure. Usually robust steel vessels containing the reactor core, that is the reactor core, and moderator or coolant, but it may be a series of tubes, sorry, it is a pressurized vessel, it's a series of tubes holding the fuel and conveying the coolant through the surrounding moderator. That's a pressurized tubes we can use there. That is also one of the major component in the nuclear reactor. Then steam generator. Here we are going to observe this is a heat exchanging chamber. Here we are going to generate the steam. And then containment. It is a structure around the reactor. What is this? We are going to observe this one is an containment. It is an structure around the reactor and associated steam generator, which is designed to protect it from the outside intrusion and the protect those outside from the effect of radiation in case of any serious malfunction inside. It is typically a meter thick concrete and steel structure. So we can call that one as an shielding. We can call that one as an shielding. This may be a steel construction or this may be an concrete construction. So it will avoid if any malpractice taking place in this nuclear reactor. That malpractice means the leakage of nuclear waste, the radioactivities. That's this contaminant will avoid that one. Now let us come to the next topic is the classification of the nuclear reactor. The nuclear reactors may be classified into different types, but based on your syllabus, uh, we are going to discuss the different types of the nuclear reactor one by one. The first thing is the pressurized water reactor. This is an construction of the pressurized water reactor. What here we are going to observe, it is a reactor. Here it's a core of the reactors. These are the fuel tubes we are going to observe, and what this is an coolant we are going to observe, and these are the control rods. By wearing these control rods, we are going to control the fusion process, the chain reaction of the nuclear fusion operation we are going to control here. And then we are going to use the coolant. That coolant may be heavy water or liquid fuel or anything. Then what the heat generated in the nuclear reactor, which is a pressurized water reactor, the pressurized water reactor, and that coolant will absorb the heat and then it will transmit it to the heat exchanging chamber. Here we are going to observe is an heat exchanging chamber. Here we are going to observe the pressurizer. That what the coolant we are going to store here, and we are going to pressurize that one by using some compressor operation. We are going to pressurize that one, and then that will be sent to the heat exchanging chamber here. And here we are going, this heat exchanging chamber is filled with an water, and through these tubes that pressure this coolant will transmit it through these tubes. After, and here the heat exchanging operation is going to taking place through these tubes, and here we are going to observe the water will absorb the heat and then it is converted into steam. That steam is sent to that steam is transmitted to the turbines to generate the power. After condensation, here we are going to observe once the steam is expanded in the nuclear turbine, that will be that expand steam is once again sent after condensation operation. Otherwise, that expand steam directly sent to this once again the heat exchanging chamber. Then the coolant will be circulating through this pipe. After heat exchange, once again it will be recycled, and once again it will sent to the nuclear reactor chamber. This is an working of the pressurized water reactor. The brief operation of this pressurized water reactor will be explained here, and you should remember that the heat produced in this pressurized reactor, normally the fuel assembly is 200 to 300 rods we are going to assemble in this nuclear reactor, and the last reactor at about 150 to 250 fuel assemble with an 80 to 100 tons of uranium. And what the temperature that generated in the nuclear reactor is 325 degrees Celsius. It is normally 150 times, it is 150 times greater than atmospheric pressure of the boiling atmospheric pressure, to prevent the boiling pressure. Then that temperature, the coolant will be transmitted to the heat exchange chamber. Then the steam will be generated in this heat exchange chamber. Then the steam will be used for generating the power. The brief operation will be given in this slide. You just go through that, and you will get a brief idea about the working of the pressurized water reactor. And the next type of one thing you should remember here, in the pressurized water reactor, we are using an coolant for heat exchanging purpose. We are using the coolant for heat exchanging purpose. In the boiling water reactor, the water is working as a reactor. Sorry, water is working as a coolant, and in the same reactor chamber, the steam will be generated. There is no coolant. There is no usage of coolant in the boiling water reactor. The water, that reactor is immersed in a water. They immersed in a, the reactor is contained in water. That water is directly converted into steam in the same chamber. Here we are going to observe the nuclear fuel, and here we are going to observe the control rods. The heat will be generated here. What the heat is generated in the nuclear reactor, it is directly absorbed by the water. There is no matter of coolant here. It is directly absorbed by the water. In the same reactor chamber itself, the steam will be generated. Same reactor chamber itself, the steam will be generated. That steam will be sent to the turbine, transmitted to turbine blades to generate the, it will be pressurized, and then it is sent to uh, then it is applied to the turbine blades to generate the power. After condensation, after expansion of that steam, the steam is once again, it will be condensed. Then the condensed water is once again pumped to the same nuclear reactor here. same transmitted to the same nuclear reactor, and it will be recycled because that expanded steam, that condensed steam, with steam the temperature of the water is high, so the generation of the steam in this reactor will very faster. So for that purpose it will be recycled. You should remember, in the pressurized water reactor, uh, the generation of the steam is taking place in heat exchanging chamber. In the boiling water reactor there is no heat exchanging chamber, the steam will be generated in the reactor chamber itself. And you should remember what the temperature generated in this pressurized boiling water reactor is 285 degrees Celsius. So the huge amount of heat is directly converted, okay, directly absorbed by the water to generate the steam. Here normally 140 tons of uranium will be used to generate 1000 megawatt of power. Here also we are going to use an uranium as an fuel. Normally, you should remember the fuel assemble comprises 90 to 100 fuel rods, and there are up to 750 assembles in the reactor core holding up to 140 tons of uranium. Now, let us come to the third type of the nuclear reactor, that is pressurized pressurized heavy water reactor. Pressurized heavy water reactor, there's a difference between the pressurized water reactor and the pressurized heavy water reactor. This pressurized heavy water reactor is also called as CANDU reactor. It is a Canadian reactor. It is first implemented in Canada. Because of that reason, they are calling this one as an CANDU reactor. In the examination, they may directly ask with a neat diagram explain the CANDU reactor. The name itself indicates the pressurized heavy water reactor. I told that heavy water is an coolant. The coolant is nothing but it is a medium of heat exchanging. For medium of heat exchanging the nuclear reactor, we are going to use an heavy water. The scientific name of heavy water is due to O. So it's a pressurized heavy water reactor. The remaining operation will be similar to the pressurized water, but here we are going to use an heavy water as an coolant here, but a little bit operation changes is there in different the nuclear reactors. The based on the candle reactor, based on the construction, based on the construction process, that arrangement of that reactor will be different. So I will explain the different types of the same candle reactor in next slide. You just observe here. Here we are going to use the pressure tubes here. Here these are the fuels we are going to observe, that the colored, the red color, that's the fuel rods, and these are the control rods we are going to observe. These control rods will absorb the neutrons, thereby the splitting of the atom will be reduces, then the heat generation the reactor will be easily controlled. And then here we are going to use an heavy water as an coolant here. Just observe heavy water, it will be recycled. That is a D2O we are going to use. D2O we are going to use this. The heavy water will absorb the huge heat. In chemistry we read about this heavy water, the D2O. Then that heavy water will absorb the heat in the core of the reactor. Then that heavy water will absorb the huge heat, and then that heavy water will be transmitted to the heat exchanging chamber. Here we are going to observe the heat exchanging chamber, and through this pipe the heat will be exchanged. The water is inside this heat exchanging chamber, it will absorb the heat from the heavy water tubes, and it will generate the steam. Then that steam will be transmitted to the turbines. Then the expanded steam is once again recycled in the steam generating chamber. Once again the heat will be transmitted to that water. Once again that same heavy water will be recycled. You should remember, it is possible to generate 1 liter of heavy water from a sorry it will possible to generate 1 liter of heavy water from a 1 lakh to 5 lakh liters of normal water. Okay, that the production of the heavy water from the normal water is a big process. In the nuclear power plant in India, we are having that conversion of normal water to heavy water process is in Tamil Nadu. So 1 liter of D2O can be extracted from 1 lakh to 5 lakhs liter of normal water. You should remember that one. And the remaining operation will be explained clearly here. You just go through that. And then so here we are going to pump, we are going to use the pump for recycling that heavy water. So for that reason, it will be named the pressurized. And these are the different method of construction of the Kandu reactor in the different nuclear power plant. They use this type of mechanism, but the operation will be simple. Here we are going to observe the two heat exchanging chamber here. Just observe that the diagram is not visible. I took from the net. So in the textbook, what the textbook I told you people to refer, in the textbook they are given this diagram. The operation will be simple. It is a nuclear reactor. The heavy water will be transmitted. That heavy water will be transmitted, and once again that can be recycled. Once again it will be transmitted to the two heat exchanging chamber. Then steam will be generated here. The remaining operation will be same what I explained in previous slide. And last type of the nuclear reactor what you get in your textbook is advanced gas cooled reactor. Here we are using gas as an coolant. That is the changes. In the previous one we can use we are using heavy water as a coolant. Here there is no coolant in boiling water reactor. There is no coolant. The water is in the reactor chamber itself. The water is directly absorbed the heat generated from the reactor, directly converted to an steam. Here it is a pressurized water reactor. Here that coolant may be anything. That coolant may be a liquid uh, liq- uh, liquid metal or heavy water or any type of uh, coolant we can use there. Now come to the gas cooled reactor. The remaining operation will be remain same. It is a nuclear reactor. These are the control rods. Here we are going to observe the heat exchanging mechanism. Here we are going to use an gas. These gas will absorb the heat generated in the core of the reactor, and then that will be transmitted to the heat exchanging chamber to generate the steam. Sorry, here these are the heat exchanging mechanism. See here, this reactor is completely uh, protected by shielding. Here it is an core we are going to get. These are the these are the fuel rods. These are the control rods. This reactor core is completely filled with gas. Okay, these this chamber is completely filled with an gas. These gases will absorb the heat from the nuclear reactor, and through the pipe we are transmitting an water. Here we are going to observe through the pipe we are going to transmit the water, but this chamber is filled with an hot gases. That hot gases heat the water in this pipe. Once the water is entering here, and what is the outlet is the steam. The water is entering here, it will absorb the heat from the gases in that the core, and then the water is slightly going to convert into a steam. Then that steam will be get outside. That will be pressurized using some economizing operation, and then that will be transmitted to the nuclear, sorry, that transmitted to an turbine for turbine for to get a mechanical output, and then we are going to generate the power. This is an advanced gas cooled reactor. We can call that one as an AGR. It is an British gas cooled reactor. Normally we are using for Maxon reactor or also graphite moderate and CO2 cooled. Here what the gas we are going to use, that will be as will be an carbon dioxide or a natural uranium. Here we are using the natural uranium fuel in a metal form, and water is a secondary coolant. The UK, the secondary coolant is an water. The primary coolant is an gas. Okay, this chamber will contain filled with an gas. The heat will be absorbed by the, here the gas will be used with the carbon dioxide. That heat will be absorbed by that carbon dioxide from the nuclear core of the nuclear reactor, and then the water will be transmitted through this pipe. Then water will absorb the heat from that hot gas. Then it will be converted as steam. Then that steam will be processed for generating purpose. This block what we are going to observe, this is an shielding. The concrete pressured vessel, we can call that one as a shielding in order to avoid that radioactive leakages. This is the working of advanced gas cooled reactor. Now come to the very important topic, that is the effect of nuclear power plants. We know that the major effect of the nuclear power plant is radioactivity. So that's a major issue in nuclear power plant. And what are the impacts of these nuclear power plants to the environment? That is very important. The waste production in this nuclear power plant is very less compared to thermal power plant using coal. There is no matter of ash. Uh, there is no matter of ash handling, and there is no matter of that dust production. So that the waste production in this nuclear power plant is very less compared to that thermal power plant using coal. And the construction is also very simple compared to the thermal power. Sorry, construction is not simple, but the construction uh, cost is very simple, very less compared to the thermal power plant. And also the carbon dioxide production in this nuclear power plant is very less compared to uh, the thermal power plant. So here some of the definition is given here, that true, the nuclear power plant may not be absorbed pollutant as coal, but chemicals it releases can be contaminate groundwater, air, and plants, and this pollution is there for decades. While the nuclear energy does not produce carbon emission directly, the construction of the plant, uranium mining, and manufacturing operation all produces CO2. But the working of the nuclear power plant will not produce CO2. And then come to the nuclear impact on human health. So it is very important. It will there may be a possibility of the radioactivity reaction. That radioactivity reaction will cause uh, it will affect the human beings by causing cancers or any other types of diseases to the human being. This is the impact of the nuclear power plant. And the next and the last topic of this nuclear power plant in your syllabus is the disposal of the nuclear waste and effluents. So you should, it is very the biggest task in the nuclear power plant. While selecting the site for the nuclear power plant, we are considering this point also, the waste disposal. We are also considering that factor while selecting the site for the nuclear power plant. The waste disposal is very important in the nuclear power plant. So before that, the waste disposal, the disposal of the nuclear waste, you should know what are the different types of wastes we are going to get in nuclear power plant, and what are the effects of those nuclear waste, and what are the form of those nuclear waste you should remember. So the based on the activity, we are going to classify the nuclear waste into low level waste. So this lifespan of this nuclear waste is less than 100 days. So this lifespan of the nuclear waste is less than 100 waste. So that type of waste we are call that one as an low level waste. And then intermediate level waste, it's an the lifespan of these waste is lesser than 30 years. So you should, after 30 years it will not affect anything to the environment, but up to 30 years we should take care of these waste. And then high level waste, this waste is a long lives, it is above 30 years. After the 30 years also, this waste may be active to affect the environment. So by considering these waste lifespan, we can decide the different way of waste disposal. And we can't say the waste sometimes that after the performance of the nuclear fuel in generating power plant, after completion of their work, we can recycle those uh, nuclear fuel by some processing operation. After some processing operation, we can recycle those nuclear fuels. So we are not disposing all the types of the nuclear waste. So we are also reprocessing those nuclear waste for uh, continuous or cyclic operation. So that is also one of the mechanism we are going to get in the nuclear power plant. The reprocessing of the nuclear fuel is very important. So if you install the nuclear tubes, that fuel tubes in the nuclear reactor, after a year or after 6 months, it will performance will be reduces, and then we are extracting that one from the reactor, and then we are going to perform some processing operation of those nuclear fuel. After sometimes we can recycle, we can reuse those nuclear fuel tubes for generating for fission or fusion operation. So these lifespan will decide the types of the nuclear waste, uh, the way of the nuclear waste disposal. The sources we can, it's an sealed source and then open source. The form of the nuclear waste is sometimes a solid, liquid, or biological. The solid is compactable or non-compactable. Liquid is aqueous or organic, and the biological form. Those nuclear waste will be biological form. These are the different forms of nuclear waste. I told that these lifespan of those nuclear waste will decides us to the different way of the nuclear waste disposal. Son, we are not. I told that we are not disposing all the nuclear waste. So those nuclear waste can be reprocessed for some other operation, or those will be reprocessed for the reprocess, or it will reprocess for some period, and then that the same used as an the same thing will be used as a nuclear fuel for cyclic operation in the nuclear power plant. Now come to the management of the radioactivity waste, how we are going to dispose those nuclear waste in these four formats. We are going, these four way we are going to dispose the nuclear waste. The first one is geological disposal. This geological disposal, the name itself indicates we are going to dispose this one in earth crust. Okay, we are going to dispose this one in earth, or we are by digging a huge land, by digging the land or huge depth. There we are going to dispose the nuclear waste, and we are going to um, fill those nuclear waste in vessels, uh, the sealed vessels, and we will perform some process operation in order to avoid the radioactivity. So we are going to fill those nuclear waste in some vessels. We are going to sealing that one, and we are going to perform some chemical operation in order to avoid the radioactivity operation. And then it will be uh, then it will be digged in then it will be disposed in a deeper land. Otherwise, under the sea, the deep sea, under the deep sea, we can also dispose this nuclear waste. That is also considered as a geological disposal. And the second one is reprocessing. I told that all the nuclear waste cannot be disposed. That can be reprocessed for the same operation, the same cyclic operation in the nuclear power plant. But this reprocessing will take the different operations. The based on those nuclear fuel, the reprocessing steps will be taking place. And then transpiration, we can convert that the nuclear waste into other form of the fuels for other operation. And then the space disposal, normally we are it is also one of the method. In the space, we are going to dispose those nuclear waste because the space is a vacuum. There is no problem of radioactivity reaction in the space because that one is an vacuum. So in the sealed vessels, we can dispose that one in a space. These are the four methods of the nuclear waste disposal. Okay, it's completes the nuclear power plant. If we get any doubts in these two classes, we can raise your questions by sending a message to me. Thank you.